This is question 39 of civil engineering paper of GATE 2017 afternoon session. A hollow circular shaft has an outer diameter of 100 mm and inner diameter of 50 mm. If the allowable shear stress is 125 megapascal, the maximum torque that the shaft can resist is. So in this question, a hollow circular shaft having outer diameter of 100 mm and inner diameter of 50 mm is given. And if the allowable shear stress is 125 megapascal for this shaft, then we need to calculate the maximum torque that the shaft can resist. So this question is from the topic of torsion. You may study about torsion and torsional equation in detail in lecture 18, Torsion 1, Strength of Material by Professor Sriman Kumar Bhattacharya, IIT Kharagpur. So as we know the torsional formula, which is T by IP equal to tau by R equal to G theta by L, where T is the torque applied, IP is the polar moment of inertia, tau is the shear stress at radial distance R, G is the modulus of rigidity, theta is the angle of twist, L is the length of shaft. So in this question we need to calculate the torque. So we know the value of IP for hollow circular shaft is pi by 32 d naught to the power 4 minus di to the power 4, where d naught is the outer diameter and di is the inner diameter of the shaft. So if we apply this equation for this question, so we need to calculate torque. So IP we can write this 5 by 32. The outer diameter is given 100 mm, and this maximum we need to calculate the maximum torque in kilonewton meter. Okay, and allowable shear stress is given as 125 megapascal. So it's better to convert all the units in one unit, means keep the all unit uniform. So I am converting this mm into meter. So this will be pi by 4 to 100 mm means 0.1 meter to the power 4 minus 50 mm, that is 0.05 to the power 4 is equal to the shear stress. The allowable shear stress applied is 125 megapascal. 125 megapascals. It means 125 into 10 to the power 6 pascal, that is Newton per meter square. Now this is radial distance. So we need the radial distance is R. So R is the outer diameter is 100 mm. So R will be 100 by 2, that is 50 mm. So 50 mm into 10 to the power minus 3. So it will be in meter. So now when we solve this equation, we will get torque T as 23,009.7 Newton meter. We can write this torque as 23 kilonewton meter. So the torque, the maximum torque that the shaft can resist is 23 kilonewton. So the correct answer for this question is 23. So the maximum torque that the shaft can resist is 23 kilonewton meter. So 23 is the correct answer for this question. Thank you.